Section 3.5, solving multi-step inequalities. We're just going to jump right into this one. Example 1 is for a solution to the inequality, 2x minus 1.5 is greater than or equal to 6. So basically, we want to know if we plug in 4 for x, are we going to get a true statement? So plugging in 4, 2 times 4 is 8, and 8 minus 1.5 is 6.5. So yes, 6.5 is greater than or equal to 6, so that means that yes, 4 is a solution to the inequality. Is it the only solution? No. Okay, there are lots of other x values that could be plugged in there to give us true statements, but 4 happens to be one of them. Example 2, this is just a bunch of multi-step inequalities. You're going to solve them very similarly to like you would an equation, except you're dealing with an inequality sign this time. The only thing that's different is you need to make sure that if you're multiplying or dividing by a negative, that you flip your inequality sign. So starting with A, we're going to want to add 12 to both sides to get the variable by itself. And we get 2x is greater than or equal to 13. Dividing both sides by 2 gives us 6.5. So x is greater than or equal to 6.5. Remember, just pick a line, call it 6.5. This is going to be a closed circle going to the right. B, if you notice, we have a set of parentheses. So this one's going to require us to distribute first. So we end up getting 6 plus 3x is less than 27. So now solving for x, if we subtract 6 from both sides, we get 3x is less than 21. Dividing by 3 on both sides, we get x is less than 7. So that is our final answer for our inequality. And then to show that on number line, we're going to have an open circle at 7, and it's pointing to the left. I'm going to let you have fun with C on your own. You got some fractions there. But let's take a look at example D. There's a lot going on. If we take a look, we can kind of split where the inequality is. On the left side of the inequality, we've got some like terms that we're going to want to combine. We have a 4x and a negative 2x. So that combines to give us 2x. And then on the right side of the inequality, we've got parentheses, so we're going to want to distribute. So we get 2x plus 14. If you notice, we right now have 2x plus 14 is less than or equal to 2x plus 14. It's the same thing on both sides. If you did not catch that, and you continue to solve for x, and you subtracted 2x from both sides, notice 2x minus 2x is gone, eliminated on both sides of the inequality. So all you're left with is 14 is less than or equal to 14. This is just like in our solving equations where we had those special cases. The variable is gone, and we're just left with the statement. This is a true statement. So since this is a true statement, that basically means that we could plug in any variable for x, and it would give us a true inequality. So if I were to just pick like 10, okay, 4 times 10 plus 14 minus 2 times 10, I'm plugging this back into the original inequality, is it less than or equal to 2 times 10 plus 7? Well, I get 40 plus 14 minus 20 is less than or equal to 2 times 17. And then if I were to simplify that, 40 plus 14 minus 20 is 34. And 2 times 17 is 34. Okay, so 34 is less than or equal to 34. Any variable that you plug in for x is going to give you a true statement. So you can say fancy R for your all real numbers, which on a number line, if you're trying to show that, basically you're just including the entire number line. So you would want to kind of just do that to show your solution is everything on the number line, because your number line is a real number line. All right, let's look at example E. So if we look at example E, we're going to have to distribute on the left side. We get 6 minus 12n is less than 5 minus 12n. If we were to add 12n to both sides, again, notice that the variables are both eliminated from both sides. So it's 6 is less than 5. That is a false statement, however, and so there is no solution for x. There's absolutely nothing that you could plug in, n in this case, there's nothing that you could plug in for n on either side of the inequality, being the same number, and get a true statement. So then this would actually be your answer on your number line as well. You would have to leave it blank because there's no number on that number line that you could plug in for n and make it work. And I'm going to have you do F on your own as well.